This video is to explain the circuit within Lab 5. Lab 5 circuit happens to be a 555 timer circuit. So as you can see here, we happen to have a 1K ohm resistor going from our, it says here that it's a 12 volt power brick. However, we're adjusting it so that it's going to be 9 volts. So we happen to have the 1K going from what we call our VCC going to pin 7, which is your discharge. Then you have a 470K ohm resistor that I have set up so that it loops down and after it loops back up to pin 6, which is your threshold. And this guy happens to loop from this white wire up to the orange, down to pin 2, which happens to be your trigger. And then you have a capacitor here that is connected directly to ground. So your output happens to be pin 3 here, which is connected to a 1K ohm resistor, and then an LED that is connected to ground. So what we're going to start off by doing is ensuring that our DMM here, which is connected directly to our input, is at 9 volts. So I happen to have waveforms up here. So I'm just going to turn this on and you'll realize that it's at 9 volts. So we're going to go ahead and shut this off and disconnect the DMM, and we're going to simply tie this whole circuit together so that basically so that all the pins that need the positive side of the supply are powered, and everyone has their ground as well. Our grounds are tied through this bus and they should all be good. So we're going to go back to waveforms and we're going to turn this guy back on. And what you'll realize is that this LED happens to blink on and off. That's because the 555 timer happens to be used as an oscillation. So it happens to create a square wave. So that's why the LED is going to be blinking on for X amount of time, and after it's going to turn off for X amount of time. So what I've done here is I've connected this green wire to the positive side of the Discovery Kit's channel 1 of the oscilloscope, and then this yellow one happens to go to ground so that we're measuring across this LED. So we're going to go back to waveforms, we're going to go to the start, we're going to go to scope, and I've already put this guy in for 500 milliseconds per division, and then channel 1 happens to be at 2 volts per division. So if we scan this, you'll see that here's our square wave, and essentially you can see how we have a on and off time of roughly they're roughly the same time that they're both at a high and at a low. If we stop this, we could take a look to see that right here is a little above 2 volts, so that's how our LED is powered. And essentially what we can determine through this is the difference between our high time and the altogether period. So say I happen to start at a time interval of -1.5, our next high time, well, our next time that we're going to go up to a high is going to be right here, which is a little less than a second off. So we're just going to take the high time here, the time at which it is at its high voltage, and then we're just going to divide that by this whole length, and after multiply it by 100%, and that's going to be what we consider our duty cycle.